there's this one question that keeps coming up in our comments, and it goes like this. How do we know how big the universe is? I mean, have they actually measured it? So, what did they use to measure it with? Okay. And how? And also, like, what's outside of the universe? Does it just keep going? Or are there, like, other universes out there? Just how big is the universe? Well, it turns out that's actually a pretty complicated question. So let's try to unpack it. The short answer is that we don't actually know how big the universe is. And that might sound weird because we can see really far away, and we have incredibly precise measurements of things like the cosmic microwave background. But those measurements only tell us how big the observable universe is, not the entire universe. And there's a pretty good reason for that. You see, the thing that we call the universe isn't just all of the stuff that exists. It's also all of space and time. Space, as in the 3 dimensions that we move around in, and time, which we experience as a dimension. Every point in space-time represents a place and a moment. So when we talk about the size of the universe, we're really asking how much space-time there is. Now, it's relatively easy to measure the size of the part of the universe that we can observe. That's the patch of space-time from the beginning of time until now, including everything that we can see. This is also called the light cone. Because if you take all the points in space-time where light could have traveled from, well, anywhere to here, that makes a cone. And we can measure this light cone. It has a radius of about 46 billion light years. That's how far away we can see. Okay. But that's not the whole story. You see, while we can look back through time by looking at distant stars and galaxies and seeing them as they were in the past, we can't look forward in time. We can only ever observe the universe as it is right now, or as it was in the past. There's no way to see into the future. So we don't know if the universe extends infinitely far beyond our observable universe. And yes, technically, the universe does extend beyond our observable universe. That's just the part we can't see. In theory, there could be more stuff in there, but we don't know. We also don't know if the universe stops expanding at some point, or if it just keeps expanding forever. As for what's outside the universe, that's even trickier to answer. Because if the universe extends beyond our observable universe, then by definition, it includes all of space and time. And that means that there isn't anything outside of it. I know that sounds kind of weird, but think of it this way. You can always imagine a bigger box, right? But if you have a box that extends infinitely in all directions, then by definition, there isn't anything outside of that box. It just goes on forever. Now, there are a lot of ideas about what might lie beyond our observable universe. Some scientists speculate that there might be other universes, but there's no evidence for this. And some say that space would begin to repeat itself if you traveled far enough, like the universe would start over again, but that's just speculation. So the bottom line is that we really only know the size of the observable universe, which is about 94 billion light-years across. As for how we measure that, we do it with a particle accelerator called the Very Large Array. It's an array of 19 radio telescopes that are each about 25 miles or 40 kilometers across. They're arranged in a circle about 3,000 miles or 5,000 kilometers in diameter. When they're used together, they can measure things related to the size of the observable universe down to the billionth of a second after the Big Bang. The way they do this is by using something called interferometry. What they do is combine the signals from all 19 radio telescopes to make one really big telescope. This allows them to measure things with incredible precision. For example, they can measure the polarization of light down to 1 part in 10 million. So that's how we know how big the observable universe is. But as for how big the whole universe is, well, we just don't know. All we know is that it's really, really big. Thanks for watching this episode. If you'd like to help us explain even more mind-blowing space stuff to the whole internet, we have a Patreon where the people who want to support the work that we do that so that we can keep doing it. You can find it at our support page.